Okay, good afternoon, everyone. We are now going to the afternoon session, lightning talk 3 from SOTM working group. There are 6 speakers for this afternoon. The first from Mr. Mark Dacosin about access disparities to evacuation centers. To present, please welcome Mr. Mark Dacosin.
So first off, welcome to the Philippines, the land of tropical cyclones. So this was taken last November, where in the span of 4 weeks, we were hit by 6 tropical cyclones and 2 of them were super typhoons. So it's important for the Philippines to have evacuation centers for people to evacuate to. But the problem is we don't have a definitive studies on the state of the evacuation center network in our country. So this is my undergraduate study. I'm going to present a part of this undergraduate study entitled the Access Disparities to Evacuation Centers in the Philippines. And so what did we do? First, we employed Dirichlet tessellation. So using this analysis, we make sure that within a given boundary, a municipal boundary, for example, and there are evacuation centers which we treated as the centroids, we will partition them to different tessellation areas to capture the least amount of travel time to go there in terms of geospatially. Although in our method, we have not taken into account road networks, which will be a future endeavor. And next, we wanted to estimate the population within each tessellation area. So we estimate the population that an evacuation center would need to accommodate in case there's an evacuation planning. So what we did here is, I'll show you a tool that we made here. So in this tool, we use OSM as a base map where you can, for example, if we're right now we're in Quezon City. Quezon City is second district, and we want to see the evacuation centers in Quezon City. We can just generate this. So we want here to develop a tool for DRM officers for better planning. So each point is an evacuation center, and for each tessellation area or service area, we can estimate the expected population that is needed to be evacuated if ever. So all of them has some value. The population was of the municipal level. It's the lowest resolution that we can have. So there's an assumption of a homogeneous distribution of population here. So that's why, for example, limitation of our study is in La Mesa Dam, where there's no population, there's small population there, but there's a high estimation since we assumed uniform distribution of population. Uh, and we also want to know if we don't constrain the evacuees within just one city. What if what if other cities outside Quezon City can accommodate others as well? So that's why we have this, which means that population within the city here is better off to evacuate in a evacuation center here, whereas the population with no shade in Quezon City is better off to evacuate somewhere else. So we did this for the entire Philippines. And this is the map for the entire Philippines, the tessellation areas showing blocker colors for major cities such as up north, there's Baguio City here. And then, of course, there's the metropolitan Manila and some other major cities such as Iloilo and Cebu. And this 2D histogram shows the distribution between the estimated population in the y-axis and here. So if there's a baseline that we set, we see that only 10% of evacuation centers in the country have a reasonable area of 5 square kilometers, meaning that it's the only area that you need to travel, and 10% of them are only servicing a population of 1,000, meaning na there's a huge gap between the number of evacuation centers and the population they need to serve. So, thank you.
Thank you so much for the insightful presentation from Mr. Mark Dickinson. And then we continue with the lightning talks, second lightning talks from Mr. Thomas Harsik with the title Post-Conference Trip Mount Pulag. To present, please welcome Mr. Thomas Harsik.
Hi, folks. It's not really a talk, it's just a question. My name is Thomas Herzig. I'm from the company called Unacast. It's a privacy-friendly location intelligence company where we help our clients understand how people move around in the real world and make informed decisions based on that. But yeah, my lightning talk is not about that. It's about love maps, and I love hiking and orienteering. And we already experienced the local culture. We will experience the city life tonight. And how about doing some exploring together, and we can experience the local nature as well. So if you are also have some spare time on Monday and Tuesday, I would love to do some hike together. And if you're interested, reach out to me, find me today, and we can plan something together. Thank you.
Thank you, Mr. Thomas Harsik, for sharing with us your trip. And then we continue with the next talks from Mr. Edneil Soriano. This is the title about using OSM to identify the busiest public transport stops in Manila. To present, please welcome Mr. Edneil Soriano.
Good afternoon, everyone. I'm Edneil. You can call me Ed, whatever. I don't really mind. I'm from the National Institute of Physics, and I'm here to present my work with May Lim. We're physicists, but don't worry, there's no math in this presentation at all. So yeah, we try to identify the busiest public transport stops in Metro Manila using OpenStreetMaps. So basically, that's what I'm gonna present right now. First, what do we mean by Metro Manila? It's technically the National Capital Region. It's not the city of Manila itself. It also includes the economic zone around it. So it's here. We can see. What we want is to identify the busiest public transport stops in this region so that we can allocate our resources effectively in improving pedestrian infrastructure, make everyone's life better. But we have limited money, so where do we allocate the money? Usually, we do boarding and lighting surveys to do this, either through traditional means, which is time-consuming and susceptible to biases in data collection, or we can use smart card systems. But PUJs, meaning jeepneys, and PUBs, meaning buses, don't have smart card systems here in the Philippines. And so we want to use an alternate method to identify where people go. We propose a method to determine these busy stops. All we need is an origin and destination matrix data, which we can get from GPS or whatever tool we can use, an OSM street network, and a GTFS feed representing the public transport network in a region. So we apply this to the Philippines, but you can apply it anywhere. Again, no BA surveys needed. So, BA surveys are static. We want to make something dynamic. And we can modify the PT network to assess proposed routes without affecting thousands of people who commute to work every day. Here, in our study, we simulated 157,000 journeys representing actual people in Metro Manila. And so we count the number of transits, meaning people who pass through a certain public transport stop, and transfers, meaning you need to switch modes in that particular public transport stop. And then we can use an arbitrary metric to determine busy stops. Here, we just made a right triangle at the top right, and we said these are the busy stops. Okay. Uh, on the left is a BA survey, a boarding and lighting survey done by our Department of Transport in 2016. And on the right are our results. It's not a one-to-one correspondence, but we can reasonably approximate the BA surveys of the Department of Transport. So it's a pretty okay method. Yeah, that's basically it. Here's a snapshot of the University of the Philippines. We're somewhere here. And so there's a jeepney stop beside us. An aggregate rank of A means busy in our scheme. And so, yeah, we were able to capture busy jeepney stops and buses without BA surveys. For summary, we proposed the model to complement BA surveys, and this model can also be used to do hypothetical public transport networks. So that's it. If you have any questions, just hit me up or something. I don't know. Yeah. Thank you. Thank you.
Thank you so much for Mr. Edneil for the insightful presentation. Okay, we will continue with talk 5 coding a web GIS platform from Mr. Arun Ganesh to present. Please welcome.
Thank you. Hi, my name is Arun. I currently living in India. I go by the OSM username PlaneMad, and I've been playing with OpenStreetMap for quite a while, and with maps and map APIs. So this is the first public demonstration of my experiments with AI and vibe coding. You've all heard of this, and I'm not sure what you've seen with things made with it. But personally, I've not seen anything very interesting. This was my own experiment using AI for creating a web GIS platform. And just to give an outline of why, I think it's a very common use case. You have a bunch of map data available. You want to publish it online. You want to add different layers. You want the ability for people to switch between different layers and compare and adjust transparency. And anyone who's tried to build a simple web page to do this knows how much of trouble it is, especially if you want some interactivity with clicking features. And for every map, you need to do the same thing. It's not something very different. So I thought, why not create an interface where we can do this, and which is also very plug and play and fully customizable that anyone can use, not just me and not limited to one region. This is the outcome of that experiment. The website is called armche.in. And honestly, I'm not even sure if this should be public, but YOLO, it's public and anyone can use it. Don't look at the source code. I haven't checked anything, no pull request, nothing. Commit, push, it's live. It runs off GitHub pages. All the source code is up, and I'll quickly show you what it can do. And just the background context of this is this was done for the state that I live in India. And the government there published a statewide land use plan. And this land use plan was published as individual village level PDFs for every single village. So that's 200 villages, which was available on the government website. And the community there decided that let's georeference all of these PDFs and put it together on a map. So it's easy for anyone to use. And for any map location, we can see what the land use plan looks like. This is the end result of that. And it started with just publishing the land use plan. That's what you'll see if you go to the website. These are all individual PDFs that were manually georeferenced in Map Whopper. And it's available here. So you could hit the geolocate button and it'll take you to your map location. Now, as someone who's been playing with map APIs for a while, I'm very familiar with the Mapbox APIs, with WebGL, and what kind of interactivity you can achieve using it. And these are all built out of the box. So some of the things you can do, it's a fully WebGL interface. It's 3D enabled. And if you've ever wanted to have vertical exaggeration or see what that looks like, you can do that on the terrain. You can overlay any map layer on this, even from any georeferenced map on map hopper you can add here. And this is the layer switcher over here. So that's 3 different layers: satellite imagery, the regional plan, and the local village boundaries. You click on any feature, you get details about it. We've also added, for the place we are in, the cadastral boundaries, which are individual plot boundaries for the whole state. And if anyone wants to see what it looks like, well, here it is. These are individual vector boundaries, and click on any feature shows the details about the boundary, and it hits the government APIs to request for the owners of that land parcel, and shows it right here. So this has completely changed how information is accessed, local information is accessed for the area. And adding a layer here is very simple. Even if you want, you can use it. So all these layers are not limited to just the place I'm in. On the top right, there's an add layer button. Here you can add a URL in multiple formats, your usual PNG, vector tile, a map hopper link, even a Wikimedia common image. If there's a map on Wikimedia Commons which has been georeferenced, you can just drop the URL to the Wikimedia image and it'll just load here. I don't have an image handy to show, or if anyone has, they could tell me, but and you can also generate a unique QR code to that particular map view. So if you scan this, whatever layers are loaded on here will get replicated on your phone. It's also mobile friendly interface. And once we added one layer, the request for multiple other layers, and just went on uncontrolled spree of adding all kinds of data layers. So this is specific for Goa. It has all kinds of natural boundaries. It has a lot of regulatory maps which control where development is allowed, where it's not allowed, coastal regulation zones, forest areas, all kinds of things. This is for the state. There are various other maps for different regions as well, which might be interesting. This is the World Atlas. And here's an interesting one. This is the real-time weather radar, which is updated every 10 minutes. Every layer has information about the data source, where it comes from. Layers which come from the NASA GIBS platform also includes time range parameters, which you can control. Any layer with time parameters gets a clock over there. So this is the latest one for today. And you can see what yesterday's image as well looked like. And go back in time for like since whichever day. And a whole bunch of other interesting maps as well. So as and when I find something interesting, we add this as a layer here. You can add the OSM base map as well. So really, it's like a map madhouse of layers. And you can add custom layers and it'll come in the URL as part of the permalink. So yeah, it's a free open tool. The source code is on GitHub. Feel free to fork. No guarantees on the source code. I have not seen it myself. It's all written with Claude cursor. Give it prompts, see if it works. If it works, push it live. Otherwise, yeah, keep trying. So this is all done in 4 or 5 months of effort in my spare time. So that's it. Thank you.
Thank you so much, Mr. Arun, for the interactive talks. And then the next talks is titled, I'd like to show my OSM commits as 3D, from Mr. Satoshi Tanaka from Japan. To present, please welcome.
Hello, I'm Satoshi Tanaka from Japan. Once I showed that this OSM commit as a 3D, I made it. this one. Oh, uh, it is the OSM 3D commit. My commit in no. I sample user commit 3D for it made it 3JS and try it. This is the username. Input the username. ALT 9800. Apply. Oh, this is heavy to connect Overpass API. Its result, my commit to 2024 OSM contribution. This is it is 2024 November 3rd. My 821 commits. Okay. Remove it, run it, and I make some function. Change color, neon, summer, autumn, spring, winter. Yes, and this is download the 3D model. Yeah, if you make a 3D your 3D model and 3D printer for 3D printer is just STL. Ooh, where's my 3D model? Oh, here, a 3D model. Oops. Yeah. Oh. This is downloaded your file STL. Yeah. Let's write your commit. The 3D. Okay. Discord source. I published the Discord. Yes. I use 3JS. The hard coding. This product is this product. Okay. Yeah. Thank you.
Thank you, Mr. Tanoshi, for impressive talk. We also like to apologize for cutting the session just for 5 minutes because this is lightning talks. And then we continue with the next talk from Mr. Maning Sambale with the title presentation is Way 445122235. To present, please welcome.
Hello, I'm Maning Sambali from the Philippines, and I wanted to talk to you about a certain way in OpenStreetMap. So this is way number 445712235, extended history. So if you open that history file, that way number, it only has 2 edits, and I think around 9 nodes and 2 tags. But there is an extended history about this way. This is actually a marine protected area in somewhere in Batangas, south of Luzon. And this was made by the fisher folks, a university, a community organizer, and a mapper like me. So when we started this, the community, the fisher folk community actually wanted to set up a marine protected area in their area. So they did a lot of community consultations for establishing that MPAs. And the one thing they wanted to do is establish this legally, because they already have a consensus around where they should be protecting their fisheries, and they want to establish this so that others do not, encroach the protected area. So the first step they did is that they do have a lot of community consultation, and then they agreed upon these are the boundaries that we should set up. So these are examples of photos there they are discussing and agreeing through consensus where they should establish their marine protected area. Then the next one is that the next step is to you install MPA markers. So in the Philippines, what they do is that they do install some buoys along the sea to establish where are the boundaries of the MPA. So we set it up. We organize a team that does this. So the first we were in 3 boats. So the first boat is like the one that who knows where it should be established. So they had to go and dive from the surface. They have to check whether if we are establishing that that buoy, want to make sure that the corals are not damaged, because you have to have like an anchor so that the buoy can be permanent, and then there's a floater that they can see that that buoy. So the first boat goes to the sea, goes to that corner, and then checks it's safe to put in the anchor in this location. And then afterwards, there's another boat, the team that brings all the equipment, the flags, the anchor, the concrete anchor, and all this equipment to set up. So this is the boat, that the team that has all those equipment, and then after that, they will put in the float. They will drop the anchor, establish put in the floater, and then have a flag that anyone can see on the surface. So this is how they do it. They pretty much dance under the sea. If you can see it, like they have three people. Someone would pull in the rope, and then someone would make sure the floater is on that location, and they will dive. And then after that, now we know the location. We have established a flag. That's when I come in and make a GPS marker. So that's not me. I'm on the other side, probably DC, for a full one full day in the ocean. So I'm doing the GPS marker, and this is the example of the GPS traces that we have. So we go around, because you cannot really do a full stop of a boat. You go around, and then you put in the marker, and then this is the boundary of the marine protected. So that's the story of that way. And what happened was, when we were doing this establishing, the municipal agriculturist came over to the community, and incidentally, there will be a municipal council discussion around how do we establish marine protected areas during that week when we were doing that field activity. So quickly, we pull out QGIS, we put it in a map, convert all those coordinates into technical description, have someone bring the USB to the main part of the town, because there's no printer in the village. Have it printed in an A4, send it over to the municipal council, and then now they have a municipal resolution that legalizes this marine protected area. So there's 3 things that has happened here. Number 1, we have converted a community consensus knowledge into a digital map that is available in OpenStreetMap. And then after that, we have a legal status that recognizes the protection, recognizes their power to enforce regulations, fishery regulations within that marine protected area. Okay, so there's 2 takeaways I wanted to share in this quick talk. First one, every node, way, and relation in OpenStreetMap has a story. So look into those stories. Maybe it's a beginner who's doing mapping. Maybe it's an expert who's doing relation boundaries. But everything has a story. So when you look at that map, maybe the edit is a little bit off, but there is a story, and we have to respect the contributions of each person in OSM. The second one is that the room here has a lot of mapping technical expertise. Find a niche in your community where you can contribute. It may be a simple, I own a GPS. I have a local community in the village that may need help. I can help you out. So it doesn't have to be a big contribution like X million edits, but it is something that will have an impact to your village or your community. So that's it. The diary is in my OSM diary post. You can go through all the details about this initiative. Thank you.
Thank you so much, Mr. Maning Sambalo, for sharing with us your knowledge.